The next what we are going to discuss the problem is the searching. The searching problem details with finding a given value called a search key in a given data set. The searching can be either a straightforward algorithm or a binary search algorithm, which is a different form. These algorithms play an important role in real life applications because they are used for sorting and retrieving information from large databases. Some algorithms work faster but require more memory. Some are very fast but applicable only to sorted arrays. Searching mainly deals with the addition and deletion of the record of values. In such cases, the data structure and algorithms are chosen to balance among the required set of operations. That's what the searching problems are. There are various methods of searching algorithm: depth first search, breadth first search, DFS, BFS. So what these searching methods do, the commonality is same, but the approach, what the common function of these two approaches are the same, but the approach, how they do the searching, in what way it differs, that's depicted by these two methods. Next is string processing. String is a sequence of characters or collection of characters. It's mainly used in string handling algorithms. Say for example, whenever a string is given and asked to count the vowels that exist in the given string, or searching the pattern in the given string, like this kind of the problems, the string processing that dealt with, most common ones are the text strings. It could be the combination of the letters, numbers, and special characters. Bit strings consist of zeros and ones. The most important problem is the string matching, which is used for searching a given word in a string text. For example, sequential searching and brute force are the string matching algorithms. The brute force technique is the commonly used string matching algorithm, although known to the grep command, which we learn in Unix programming. So that the kind of the searching, the string processing that it deals with the regular expression patterns. All these are the examples of string processing. Next is the graph problems. It's one of the interesting area of algorithmic design and analysis. A graph is a collection of points called vertices, which are connected by line segments called edges. Graphs are used for modeling a wide variety of real-life applications such as transportation and communication networks. One of the interesting area in algorithmic is graph algorithms. A graph is a collection of points called vertices, which are connected by line segments called edges. Graphs are used for modeling a wide variety of real-life applications. The graph problems, it includes a graph traversal, shortest path, and topological sorting algorithms. Some graph problems are very hard, and very small instances of the problems can be solved in realistic amount of time, even with the fastest computers. There are two common problems that are solved by using graphs. One is a traveling salesman problem. The goal of this problem is finding the shortest route through n cities that visits every city exactly once. The graph coloring problem is to assign the smallest number of colors to vertices of a graph so that no two adjacent vertices are of the same color. This is the second type of the problem that is really useful by solving by the graph coloring problem. Is to assign the smallest number of colors to vertices of a graph so that no two adjacent vertices are of the same color. It arises in event scheduling problem where the events are represented by vertices that are connected by an edge. If the corresponding events cannot be scheduled in the same time, a solution to this graph gives an optimal schedule. The next variety of problem is the combinatorial problem. The traveling salesman problem and the graph coloring problem are some of the examples of combinatorial problems. These problems that ask us to find a combinatorial object, such as a permutation combination of a subset that satisfies certain constraints and has some desired costs as well. These problems are difficult to solve the following facts. First one is the number of combinatorial objects grows extremely fast with the problem size. Second is there are no known algorithms which are solved in acceptable amount of time. Next is the geometric problems. The geometric problems deal with the geometric objects such as points, lines, and polygons. It also includes various geometric shapes such as triangles, circles, etc. The applications for these problems are the computer graphics and robotics. The two problems most widely used are the closest pair problem and convex cell problem. The closest pair problem is the given endpoints in this plane. We need to find the closest pair among them. That's what the closest pair problem is. Convex hull is to find the smallest convex polygon that would include all the points of the given set. The last class of problems are the numerical problems. This is another large special area of applications, whereas the problems involve mathematical objects of continuous nature, solving equations, computing definite integrals, and evaluating functions, and so on. These problems can be solved only approximately. It's for approximation. These require real numbers which can be represented in a computer only approximately. It can also lead to an accumulation of the round of errors. The algorithms designed are mainly used in scientific and engineering applications. Here we complete each and every details about the important problem types.